Video number 40 plus. Orders of magnitude and common sense. Hello everyone. Today's video is related with the two previous ones on scale effects and dimensional analysis. It is perhaps also an opportunity of bringing to the general public a slightly different view on the form of mind of professional physicists. Point 1. The sense of reality in physics. You certainly heard during your physics courses such sentences as, "We will neglect the first approximation such an influence," or "The behavior of this system depends only on such and such factors by neglecting this and that." What does that mean exactly? In today's world, where we are deluded by alleged theories of everything, quantum computing to come, and artificial intelligence popularized by chatbots, so many illusions which will find their limits in any case, we are induced to believe, and this is always a mistake, that we can forget common sense. Common sense in physics can be summed up in two sentences. First, the macroscopic objects of everyday life are subject to influences of an unattainable complexity, and it will always be the case for reasons of scale, with or without a computer. Secondly, if one does not make a reasoned choice of those influences that one keeps in the equations, it is impossible to calculate or even to estimate anything, even for a particular problem of everyday life. Consequence, in practice, we work on false models and we must never forget it. The choice of the most effective model is linked to the consideration of the orders of magnitude, which makes it possible to compare the different influences governing the behavior of the system under study. Point 2. The powers of 10. In the Western world, which has been leading the science boat for about 3 centuries, and especially since the French Revolution, we used to count and calculate a decimal numeration system whose origin is quite simply the number of fingers of our 2 hands. In this system, the powers of 10 play an essential role, and our apprehension of orders of magnitude is expressed from them. There are now very nice-looking books, web pages, and even videos where these powers are illustrated by examples from astronomy or particle physics. But today, we'll try to be a little more pragmatic, if possible. To begin, we show in the table the first powers of 10, positive or negative, to avoid any ambiguity later. By convention, 10 power 0 is equal to 1. Then, 10 power 1 equals 10, 10 power 2 equals 100, 10 power 3 equals 1000. On the other side, 10 power minus 1 equals 0.1, 10 power minus 2 equals 0.01, 10 power minus 3 equals 0.001. The powers of 1,000, 1 million equals 10 to the power 6, 1 billion equals 10 to the power 9, etc., have historically played an important role and made it possible to better realize what large numbers represent, at least for the generations born before the invasion of pocket calculators. Their importance comes from the fact that space is three-dimensional. Point 3. The notion of order of magnitude. In practice, two physical quantities are said to have the same order of magnitude if the ratio of their measurements, taken in any order, is between 10 and 1/10. To allow easy comparison of numbers representing physical quantities, scientific notation is traditionally used. We write, for example, 6,400 equals 6.4 10 power 3. 225 equals 2.25 10 power 2. 300,000 equals 3 10 power 5. 0.029 equals 2.9 10 power minus 2, etc. The power of 10 involved in scientific notation is, by definition, the order of magnitude. We consider a quantity capital B negligible compared to quantity capital A of the same nature if capital A overpasses capital B by at least 3 orders of magnitude. And we write B much smaller than A. For example, the distance covered by light in 1 second exceeds the terrestrial radius by 2 orders of magnitude, the terrestrial diameter by only 1 order of magnitude, which may seem odd, since they are in a ratio of 2, and shows that this notion of order of magnitude is only interesting to express very large or very small ratios. Of course, the notion of negligible quantity depends on the context, but rare are the fields where the relative uncertainty of the measurements is lower than 10 power minus 3. This is why it is often said that only the first 2 significant digits make sense for a measurement or the result of a calculation. Point 4. The importance of orders of magnitude. This notion is important, the main idea in science being to avoid the tree that hides the forest. In our daily reality, of course, it is even more important. Any rational choice being based on the correct evaluation of the relative importance of the elements of a concrete situation. And unfortunately, to take just one example from daily life, many commercial techniques consist in making the customer lose the north by pushing them to overrate things that are not really important and to undervalue what is fundamental or costs more to optimize at the production level. You will see this in all areas of consumption. For example, the color of a fruit is much less important than its taste quality and its concentration of vitamins. 2 things that are much more difficult to optimize than color. This is called the dictatorship of appearances, which in principle the scientific brain is well equipped to resist. At least, that is what we hope. Otherwise, the democratized teaching of science will have missed its main objective, which is to develop a critical mind based on observation and common sense. Point 5. The tree that hides the forest in physics. Here is another opportunity to insist on some obvious facts that are rarely underlined by the media, yielding a little too easily to the spectacular and the fantastical aspects of research. These aspects are obviously more selling than rationality. Research in physics has stagnated for more than 50 years, while technology is making explosive progress. It is not by chance, but precisely because we have chosen to invest in the tree that hides the forest, instead of continuing to study the fundamental problems of matter, energy, and light. We have tried to find solutions concerning the 2 extremes of the scale of magnitude, cosmology and particle physics. But we must understand that on one hand, the galaxies located 10 billion light-years away will never have any influence on us before the disappearance of the species, while on the other hand, we will always be unable to modify anything. The particles will continue to lead their eternal dance without worrying about the observer, whose importance has been exaggerated a little too much in an anthropocentric approach, that I have already criticized in a previous video. Point 6. About common orders of magnitude. We are used to handling lengths ranging from meters to millimeters, weights or rather masses ranging from grams to kilograms, but the milligram or the ton are less familiar to us. Yet, we mean the milligram and the ton daily without realizing it. Weight of a fly or a grain of rice, a few milligrams. Weight of a car or a truck, a few tons. Weight of air in an apartment, a few hundred kilograms. Yes, 1 cubic meter of air weighs more than a kilo, and the air in an apartment takes up a few hundred cubic meters. Around 100 for a 40 square meter studio. I end with 2 questions. First question, how many grains of rice in a 1 kilogram package? Try to count them. It will take more than 10 hours. Second question, how much do you think the air contained in St. Peter's Basilica of Rome weighs? I bet many will be surprised. It's not much lighter than the basilica itself. The weight of walls is only 1 order of magnitude above. The weight of the air inside a large building is not negligible by our definition. Point 7. What I can't do for you. As a matter of fact, to visualize things such as 1 billion light years in kilometers, 10,000 billion billions or 10 power 22, the number of atoms in a grain of sand, 10 power 20, an A4 theory is the number of atoms in the universe, 10 power 80, is beyond anyone's capability. The videos that you can see on the issue here and there present a traveling from the infinitely large to the infinitely small, or vice versa. But it is impossible for a human brain to globalize the result. This is why it is a little dangerous that all the attention of the media is focused on research where this type of numbers is the daily bread. The risk is to convince the general public that one should not try to represent things to oneself, and that they accept an environment of abstract numbers without any grip allowing them to exercise their common sense. Working in the abstract does not make you smarter, as the great physicist Erwin Schrödinger observed in his book Mind and Matter in the 50s. Reality exists. You and I have met it, and it dominates all theories, since none of them will ever contain the entire reality.